Welcome to the HEOR Insights YouTube channel. In this explainer, we're going to break down the development, documentation, and verification of a systematic search strategy, a core skill within health economics and outcomes research.
We'll begin with the foundational principles, then walk through the step-by-step development process. After that, we'll cover key search techniques and the industry standards for verification. And finally, we'll connect it all back to how you'll use this in a professional HEOR role. So first, let's establish exactly what a search strategy is and why its systematic nature is absolutely non-negotiable for any evidence generation in HEOR. A search strategy is a formal, documented plan you use to retrieve data from bibliographic databases. This isn't like a quick Google search. It's much more like a scientific protocol. It has to be designed from the ground up to be reproducible, transparent, and comprehensive, ensuring the entire process can be audited and replicated by anyone.
You've probably heard the phrase garbage in, garbage out. Well, it's a fundamental truth here. The quality of any economic model or systematic literature review depends entirely on the quality of its inputs. A flawed search strategy that misses a single pivotal trial can completely invalidate an analysis, and that could even lead to a negative recommendation from an HTA body.
When you develop a search strategy, you're constantly balancing two competing goals: sensitivity and precision. In HEOR, we almost always prioritize high sensitivity. This means we're willing to accept lower precision and sift through more irrelevant results because the risk of missing even one critical piece of evidence is just too high, especially when patient access and reimbursement decisions are on the line.
Okay, now let's outline the structured four-phase process for actually developing one of these search strategies.
The core methodology we use is called the block building approach. It's pretty intuitive. Each main concept from your research question is developed as its own separate block of search terms before you combine them all at the end.
The process starts by conceptualizing your research question using the PICOS framework. That's population, intervention, comparators, outcomes, and study design. From there, you identify your search terms, draft the master strategy in a primary database like Medline, and then finally, you translate that strategy so it works in other databases.
Now, even though PICOS helps structure the question, we often deliberately leave the comparator and outcomes concepts out of the search logic itself, and you might ask why. It's because including them can accidentally filter out relevant studies that might not explicitly mention the exact comparator or outcome in the abstract. Again, it all comes back to maximizing sensitivity.
In this section, we'll get into the specific techniques you'll use to construct a search that's both comprehensive and efficient.
For a search to truly be comprehensive, each concept block has to combine two types of terms. First, controlled vocabulary, like MESH and Medline, which are standardized tags. And second, free text keywords. Using both is absolutely critical, because an indexer might not have tagged a new article yet, or authors might just use different words. A good search has to capture both scenarios.
Boolean and proximity operators are the logical tools we use to combine all these terms correctly. The OR operator is used within a concept block to group together synonyms and broaden that part of the search. Then, the AND operator is used between blocks to find where those concepts overlap. We also use tools like truncation, usually an asterisk, to find word variations, and proximity operators to find words that appear close to one another. Let's make this more concrete. Say we're building a search for economic evaluations of semaglutide in type 2 diabetes. We'd start with our first concept block, the population. This block would combine the official MESH term for diabetes mellitus type 2 with various free text terms like diabetes type 2 and the acronym T2DM. Our second block would focus on the intervention. Here, we'd combine the MESH term for semaglutide with free text searches for its generic name, its brand names like Ozempic and Rybelsus, and maybe even its broader drug class, GLP-1 agonist. This ensures we capture studies that might discuss the drug class as a whole, not just the specific drug.
The third block is different. It applies a filter to hone in on a specific study design. Since we need economic evaluations, this block would use a pre-validated filter that's full of terms related to costs, economics, and pharmacoeconomic analyses.
And for the final step, we combine our three separate concept blocks. By using that AND operator, our search will only retrieve records that exist at the intersection of all three concepts. So studies about type 2 diabetes that mention semaglutide and are also identified as economic evaluations. A search strategy is really incomplete without formal verification and documentation. These steps aren't optional. They're required for publication and for any submissions to health technology assessment bodies, or HTAs.
The industry standard for quality control is the PRESS guideline, that stands for Peer Review of Electronic Search Strategies. It's a formal checklist that a second, independent information specialist uses to review the strategy. This peer review is crucial for catching errors in logic, missed terms, or even simple typos before you run the search.
Now for documentation, we follow the Prisma S guideline. This standard dictates exactly how a search must be reported. You have to state the database, the search dates, any limits you applied, and you must provide the full line-by-line search logic. This directly supports those core principles of transparency and reproducibility we talked about earlier.
You also need to be aware of some common pitfalls. For instance, using the not operator improperly can accidentally exclude relevant papers. Forgetting to include all the brand names for a drug is another common mistake. And of course, getting confused by the specific syntax of different database interfaces can cause your search to fail entirely.
Finally, let's connect this very technical skill to how it's directly applied in common HEOR and market access jobs.
This rigorous process is the absolute foundation for conducting systematic literature reviews for HTA submissions. It's also used to run targeted searches to find specific inputs for economic models, things like utility values or costs. And it's essential for identifying the full body of evidence you need for network meta-analyses.
So, thinking about that question on the slide, here's how you could frame it. In an interview, you'd explain that a peer-reviewed search strategy is critical because it ensures every subsequent analysis, whether it's a literature review or a complex economic model, is built on a foundation of comprehensive and unbiased evidence. It's the essential quality control step that underpins the credibility of all our work, which makes it a core competency for any HEOR professional.